Welcome to the session Direct Proportion. By studying this lesson, you will be able to identify direct proportions and how to solve problems related to direct proportion using the unitary method, using the definition method, and also using the algebraic method through the equation y equal kx. At last, you can learn how to solve problems related to the conversion of foreign currencies using the knowledge on direct proportion. Okay, let's try to understand what is direct proportion through this table. The table shows number of pens and the corresponding price depend on the quantities of pen. Here, number of pens taken as the first quantity and the corresponding price taken as the second quantity. When you go through the next table related to the first one, here the ratio of the number of pens and ratio of the corresponding prices. When you get the ratio of the number of pens between the first and the second, so the ratio of number of pens is 1:2, and when you compare the ratios of the corresponding prices, 15:30, which is equal to 1:2. Once again, if you are taking one more ratio, 1:4, the first one and the fourth one of the first quantity, 1:4, what is the corresponding second quantity for 1:4? 15:60. So 15:60 when simplified, once again 1:4. Likewise, when you get 3:1, the ratios of pens and the corresponding prices 45:15, again, which is equal to 3:1. So by observing the above table, it is very clear that the ratio of the number of pens is equal to the ratio of the corresponding prices. So, two distinct quantities are said to be direct proportions if they increase or decrease in the same ratio. According to the above table, the ratio of the number of pens is equal to the ratio of the corresponding prices. Therefore, direct proportion meaning two distinct quantities, first quantity, second quantity. Two distinct quantities are said to be direct proportion if they increase or decrease in the same ratio. Here the ratio is 1:2, here too 1:2, 3:1, 3:1. So, therefore, if two quantities are in direct proportion, then when one quantity increases, the other quantity will also increase in the same ratio. Similarly, if two quantities are in direct proportion and one quantity decreases, then the other quantity will also decrease in the same ratio. Let's study more about direct proportion through these examples. For each of the cases given below, write whether direct proportions or not. First one, the number of meters of cloth and its value. Here, to decide whether direct proportion or not, just we want to check whether one quantity increases, the other quantity is also increased by the same ratio or not. Here the number of meters is the first quantity, the value is the second quantity. Let's assume 1 meter cost rupees 100, then 2 meter cost 200, 3 meter costs 300. So when you consider the first quantities ratio, which is equal to the ratios of the second quantity. 1 meter 100, 2 meter 200, 3 meter 300. So the ratio between the first quantity is equal to the ratio of the second quantity. That means when one increase, the other also increase by the same ratio. Therefore, the first example or the first statement is direct proportion. Let's go for the second one. The length of a side of a square and its perimeter. Here the first quantity is length of a side, second is perimeter. Once again, let's check whether this relationship is direct or not. If the length of a side of a square is 1 centimeter, perimeter is 4 centimeter. 1:4. Suppose if the length of a side is 2 centimeter, the perimeter is 4 times 2, 8 centimeter. Therefore, once again it is clear the ratio of the first quantity 1:2, here to perimeter 4 to 8 mean once again 1:2. Therefore, here too, when one quantity increases, the other is also increased by the same ratio. Therefore, second statement is also direct proportion. Let's go for the third one. The radius and the circumference of a circle. When the radius is the first quantity and the circumference is the second quantity, when you substitute some values and check the circumference of the corresponding radius, once again it is clear that this is going to be direct proportions, because if radius is r, circumference is 2 pi r. Here 2r, once again 2 pi into 2r. So when one quantity increases, the other, when radius is increases, the circumference is also increased by the same ratio. Therefore, it is to direct proportions. Let's go for one more. The fourth one, the number of men needed to finish a task and the number of days taken for it. Number of men. Let's assume that 2 people or 2 men needed 1 day. 2 men needed 1 day to finish a certain task. So 2 men needed 1 day. Then I am asking you, if 1 man assigned for the work, how many days needed? If 2 men needs 1 day, 1 man need 2 days. Therefore, here when one quantity increases, the other decreases. Number of men ratio and the number of days ratio are not same. Therefore, when one quantity increases, the other not increase by the same ratio, then this is not direct proportion. One more. The length of a side of a square and its area. When you get the length of a side and its area and see the relationship between the two quantity, the length is 1 centimeter, the area is 1. The length of a side is 2 centimeter, here 4. So therefore, by observing that, and when you compare the ratios of length of a side and the area is not in direct proportion. So therefore, it is to not a direct proportion relationship. And one more, the last, the speed of a vehicle and the time taken. Speed of the vehicle is taken as the first quantity and time taken is the second quantity. When you travel with a speed 50 kilometer per hour, let's assume that it takes 2 hours to reach the target. 50 speed, 2 hours. Then when you increase the speed up to 100, then the time taken going to be 1 hour. Therefore, when one quantity increases, the other here decreases. Therefore, this relationship or this statement also not in the direct proportion. Let's see how to solve problems related to direct proportions. In fact, there are 3 methods of solving problems related to direct proportion. The first one is unitary method. So solving problems related to direct proportion using the unitary method. So what is unitary method? The method of solving a problem based on the value of a unit is called the unitary method. In the given problem, we need to find the value of 1 and then solve the problem. Let's see one example how to solve problem using the unitary method. A vehicle travels at a constant speed, take 8 minutes to travel 4 kilometers. Find the distance it travels in 5 minutes. So in 8 minutes, 4 kilometers. In 5 minutes, how many kilometers? Let's try to solve this using unitary method. Therefore, let's write distance traveled in 8 minutes in meters, 4,000 meters. Let's find the distance traveled in 1 minute in meters, 4,000 divided by 8 will gives us the distance traveled in 1 minute, that is 500 meters. So according to the unitary method, we should find the distance traveled in 1 minute. After that, we can calculate the distance traveled in 5 minutes in meters, which is 2,500 meters or 2.5 kilometers. Solving problems related to direct proportion using the definition. Let's see how to solve direct proportion problems using the definition method. Once again, let's go through an example. If a motor car travels 75 kilometers on 3 liters of petrol, find the distance it can travel on 7 liters of petrol. So let's go for the amount of petrol and the distance as 2 quantities. Here in 3 liter, the given data, distance traveled 75 kilometer. Therefore, in 7 liter, how many kilometer? 3 liter, 75 kilometer by 7 liter, how many kilometer? So according to the method, we should use the definition. So what is the definition? Definition method says the ratio of the first quantity equal to the ratio of the second quantity. So the basic concept of direct proportion is the ratio of the first quantity should equal to the ratio of the second quantity. Since this is a direct proportion problem, the ratio of the first quantity should equal to the ratio of the second quantity. So when you write the relationship as an equation, 3:7 equal 75:x. The ratios can also be written in the fractional form, 3:7, 3 over 7, here 2, 75 over x. By cross multiplying, we can get the equation 3x equal 525. By solving or by divide both sides by 3, x equal 175. So x meaning the distance traveled with 7 liters of petrol. Therefore, the distance it can travel on 7 liter of petrol is 175 kilometer, and this method is known definition method. Here we should use the equation which is the first quantity's ratio is equal to the second quantity ratio. Okay, solving problems related to direct proportion algebraically. Let's see how to solve problems related to direct proportions by algebraically. To understand this, let's go through the table once again, which is we discussed earlier, number of pens as first quantity and the corresponding price as the second quantity. Through the table, it is clear that when you get the ratio, the division, the ratio of money spent and the number of pens is equal to a constant value. For example, here money 15, corresponding number of pens 1, so 15 over 1, 15. Or 30 divided by 2, 30 divided by 2, again 15. Or 45 over 3, again 15. So when you get the ratio between the money spent and the number of pens, you will get the same unchanged equal answer, which is called constant. Therefore, we can write according to the last row, y over x equal k, where k is constant. Price over number of pens is a constant. Therefore, in the last row, get the variable y over x equal k, where k is a constant. By cross multiplying, we can get the equation y equal kx. So, solving problems related to direct proportion algebraically, meaning we are going to solve problems using the equation y equal kx, where y is the second quantity, k is the constant value, and the x is the first quantity. To understand more about the algebraic method, let's go for an example. If the daily wage of 6 laborers who are paid equal wages is rupees 7,800, find the daily wage of 5 laborers. So here, the first set of data, 6 laborers paid 7,800 rupees. And the question is, for 5 laborers, how much? The wage. So let's substitute x equal 6 and y equal 7,800 in the algebraic method equation y equal kx. When you substitute the value in the equation y equal kx, y 7,800, k is unknown, and x equals 6, second quantity, then the k constant value, and the first quantity. By solving this equation, we can find the value of the constant k, which is 1,300. So using once the equation y equal kx, let's find the value of constant, that is k here, 1,300. After that, let's substitute the second set of data. 5 laborers. Then x equal 5 and k is already known, 1,300. Then the question is, how much is the value of y? So when you use the equation y equal kx second time, here x is known, k is known, we can find the value of y. When you substitute the values, y unknown, k 1,300, x equal 5. So by solving this, you can get y equal 6,500. So here in this method, we need to apply the equation y equal kx twice. First time, using the first set of data, we can find the value of the constant. Second time, using the value of constant and the second data, we can find the corresponding y value using the equation y equal kx. Therefore, the daily wage of 5 laborers is rupees 6,500. Let's see how to solve problems related to the conversion of foreign currencies using the knowledge on direct proportions. The rate at which one country exchanges its currency with that of the another country is called the exchange rate. Example, if the price of a mobile phone imported from USA is 220 American dollars, find the value of the phone in Sri Lankan rupees. So the value here, the value of the phone is given in American dollars. We need to find the value of the mobile phone in Sri Lankan rupees. Here it is given 1 American dollar is equal to 186.25 Sri Lankan rupees. So using this, we can find the value of the phone in Sri Lankan rupees using this exchange rate. So let's see how to find the value. Value of an American dollar is rupees 186.25. Then the value of 220 American dollars. The value of 1 American dollar, 186 rupees 25 cents. Therefore, the value of 220 American dollar is 186.25, should multiply by 220. So we can find the value of the mobile phone in Sri Lankan rupees, which is 40,975. Here students, the question is find the value of the phone in Sri Lankan rupees. Therefore, we are keeping the Sri Lankan rupees in the right side. The data is American dollar. We are keeping that in the left side. So we need to make the relationship between the American dollar and the Sri Lankan rupees by keeping the questions always in the right side. So $1, 186.25, therefore $220. By multiplying, we can get the answer. Let's see one more example related to foreign currencies. Example number 2. A pilgrim who travels Saudi Arabia converts 188,700 Sri Lankan rupees into Saudi Arabia Riyal. How many Saudi Riyal does he receive? Here, 1 Saudi Riyal is equal to rupees 51. As we discussed in the previous case, let's keep the question in the right side. Question is how many Saudi Riyal? So let's write like this. The value of 51 Sri Lankan rupees is equal to 1 Saudi Riyal. 51 rupees equal to 1 Riyal. Then 188,700 rupees is equal to how many Riyal? So we should divide 188,700 by 51 to calculate, to find out how many 51s are there in 188,700. So when you divide, the answer 3,700 Saudi Riyal. So this person will get 3,700 Saudi Riyal.